Good morning, everyone. Today we are going to do chapter number 11, constructions. And if you remember, I had indicated that out of the 3 constructions given in your textbook, one has been deleted this year. So we will be doing construction for how to divide a line segment in a given ratio. Then afterwards, there is construction of similar triangles. This one has been deleted. So you can just write down for yourself. And based on this deletion, from your first exercise, we shall only be doing question number 1 and rest of the questions will be deleted. So from exercise 11.1, we are going to do question number 1. The rest of the questions of this exercise will be deleted. So you can just mark for yourself. Question number 2, 3, 4, 5, 6, and 7. These are all deleted. These are based on similar triangles. Construction of triangles similar to the given triangle. Let's see what we have here. To divide a line segment whose length is given and a point which divides that line segment internally in the given ratio, you need to obtain that point. There are 2 ways to do this. I will be taking up the second one, which is actually easier compared to the first one. You will see that in your textbook also there are 2 methods given for this division of a line segment given ratio. So this is the first method right over here. Steps of construction are indicated and the construction has been justified. Later, alternative method is given, and this is the one I will be using, the alternative method. So I will be doing the first question from the exercise, and side by side I'll explain how to do that. So first thing we want to do is we want to start with the line segment of the given length. So I'll be using my ruler. I need a line segment of length 7.6. Let's name the line segment as AB, and I can write down that AB here is 7.6 centimeters. This is the first step. Draw the line segment of the given length. Next thing I want to do is I want to draw 2 lines parallel to each other. So I'm going to draw a pair of parallel lines passing through point A and point B, and that can be done by drawing 2 alternate interior angles of the same measure at endpoint A and at endpoint B, but on the opposite side. So I'm going to construct an angle over here. Whatever is the measure of this angle, I'll be constructing an angle on the opposite side at B. Since the alternate interior angles will be equal, we will have these rays parallel to each other. This is what I'm going to do. So to do that, you can either use your protractor or you can construct it using compasses. Right now I'm using a pair of compasses to construct a pair of equal angles. So you choose a fixed radius, and from the endpoint A, you draw a semicircle, and then the point where the semicircle touches, I have not drawn that properly. Let's just draw it again. Okay, so this is what I have. At this point, keep your compass, obtain an angle of 60 degrees. I'm going to obtain an angle of 30 degrees at both the endpoints. So this will be an angle indicating 60 degrees. I would like to get an angle of 30 degrees. And for that, I'm going to bisect the angle of 60 degrees. So when I join the vertex to this point of intersection, I will be obtaining an angle of 30 degrees. I will do that. So you place the ruler in order to connect those 2 points, the vertex and the point of intersection, and you draw an arm. and let's name this as X. This angle here is 30 degrees. So you can just leave it. You don't have to write that. And I want to do the similar thing from the other endpoint, which is B. So I'm going to use the compass and let's go to the endpoint A, draw a semicircle, then from this end, draw an angle of 60 degrees. And then bisect the angle of 60 degrees in order to obtain an angle of 30 degrees at vertex C. Sorry, vertex B. And remember to keep the radius same so that you have the measure equal at both the endpoints. Let's name this as BY. So this angle again is 30 degrees. What we have is the ray AX is parallel to the ray BY. This is the second step. And these have been obtained by constructing two equal angles at vertex A and vertex B. The next thing we want to look at is the ratio in which we want to divide the line segment. This is the second thing we will be using from the question other than the length of the line segment. So the length of the line segment is 7.6. We started with this. Then at both the endpoints, we have drawn acute angles in such a way that the arms of those angles are parallel to each other. We want to divide the line segment in the ratio 5:8. This is most important. We will be now dividing those arms into equal parts. So the arm AX and the arm BY will be divided into equal parts, keeping in mind the ratio that we require. The ratio that we require is 5:8. So I will be dividing this arm AX into 5 equal parts. I'll be putting marks here. It's like cutting off arcs at equal distances, and I'll be cutting off 5 arcs along AX and with the same radius. This is very important. With the same radius from B along BY, I'm going to divide or cut off arcs 8 times. Now this time I'm going to fix the radius. I'll be using the radius as 1 centimeters, and then let's measure. Bringing our compass here, let's open it 1 centimeter. So let's just change. And then fixing the radius. From A, I think I changed the radius. This is 1, then this is 2, 3, 4, and 5. And you can name these as A1. The second point can be named as A2. The third can be named as A3. Fourth one can be named as A4. The fifth one can be named as A5. This was for A, and now I'm going to do 8 at B. One, two, three, 4, 5, 6, 7. I think I need to fix the last one. Let's go back here. So I have 1, 2, 3, 4, 5, 6. I need the 7th one and then the 8th one. This is the 8th one. And I'm going to name these. This is B1, this is B2, this is B3, this is 4th, B5, B6, B7, B8. This is also done. The last step of the construction is to join this 5th point with the 8th point with the help of a ruler. So place your ruler in such a way that the arc indicating A5 is connected to the point indicating B8. So the last point along the arm at A should be connected to the last point along the arm at B. This point will be point P, and AP is 2. PB will be 5 is to 8. And you can measure the paths AP and PB in order to verify that the line segment has been divided in the given ratio. As you can see here, the length of the part AP is 2.9 approximately, and you can measure the length of the remaining part PB and then find out the ratio. It will be 5 is to 8.